Morning, everybody.
Good morning.
We are here today with Tom teacher, Patty teacher, and Andy teacher.
Nice.
And we're going to be doing today a class with a little bit current.
We do hear this often. You're here.
Oh, Yuri's in there. Hello,
Hi,
Yuri.
Yuri.
So far, just Yuri and 16 mystery people. If you join in the chat, feel free to say hello.
Good morning.
Morning.
Start with just a little warm-up. They'll be with our air, our water, ash, coal, riding the bus, walking, and air conditioning. So this one, you can tell us maybe in the comments what you think. Do you think trash is good, trash is bad, tree good, tree bad? What do you think?
Well, we have a couple people before we start. I see Jenny. Hello, Jenny.
Hi, Jenny.
Jamie.
Sure.
Uni and Chloe. Hello.
Hello.
Hi.
And Yun. I'm not sure who that is.
Hayun is
Hayun?
usually
Hayun?
Grace.
Grace? Oh, okay.
Gloria.
Hi,
Gloria.
Grace.
Someone. There's Jaden, but I don't think that's.
Jaden.
I think it's a different Jaden. All right. Well,
Hi.
hello.
So you can tell us in the chat what you think for what's on the screen now. Do you think these things are good for the environment or bad for the environment? So think about them carefully.
Which ones
I
are
think-
good?
yeah.
How about that?
So actually, I think we can think about these for at the end. At the end, we'll talk about how we can help the environment. So thinking about these now will help you for later. So shall we get started with our reading?
Yes. So
Right,
let's-
so today we'll read this article, which is about climate change. Now this is quite small, but don't worry, the writing will get bigger.
all right.
Right, so let's just start first with vocabulary words. So first vocabulary word is
Ooh.
climate.
Climate.
Climate. So Paddy teacher, what is climate?
Sure, I can read it there. Climate is the average pattern of weather conditions over a long period of time. Climate isn't weather. Weather changes daily.
Yeah.
So the way I like to think of it is that weather is how the temperature and what the weather is doing for one day, where the climate talks about a long period of time. So
Yeah.
what is the weather in a country for the whole summer, maybe?
Yeah.
Is it a hot climate or a wet climate?
Right.
So climate is like over a long period of a year or a season.
So for example, the weather today in Busan is cloudy. So maybe in Canada it might also be cloudy today. So Canada and Korea have the same weather today, but do they have the same climate all the time?
No.
Is it the same? No.
Canada is much colder
Yeah.
in the winter than Korea is. So the climate of Korea is pretty much a warm winter, whereas Canada has a very cold,
Yeah.
cold winter.
So the climate is different. So the weather can be the same, but the climate is different. Right, our next word, our next phrase is global warming. Global warming. So this is a word we hear a lot in the news. If you listen to the news in
the last
English,
few years.
you'll hear this word a lot. So Andy teacher, what is global warming?
So what global warming is, it's the increase in Earth's average temperature over a long period of time. So it's kind of talking about, as time goes on, scientists are tracking that it's getting a little bit warmer year after year. And what they're not sure of, many, they seem to have a good idea. Are people the reason for global warming? Is the Earth warming itself? Because sometimes it is natural. There's been times when the Earth has gotten warmer or colder in history. But when overall around the Earth it's getting warmer, it's called global warming, is the idea.
So people think this is happening a lot now. So for example, 2019 was hotter than 2018. And they think 2020 will be hotter than 2019.
Right.
And it will keep getting hotter and hotter each year.
And Sophie, hello.
Hi,
Hello.
Sophie.
So we have Luna and Sunny.
Right.
Hello, or Luna Sunny.
Right. And we have some trees good, I see. Yeah.
Trees
That's
are good.
Good.
Recycling is good.
Recycling is good. Yeah, excellent. Right.
Good.
I keep those.
Anna, hello to Anna too.
Hi, Anna.
Hello.
Right. I'll keep those answers coming in. It's very good that.
Yeah.
Right. Our next word is
Hi, Ricky.
carbon dioxide. Oh, this is quite a long, difficult term, actually. So carbon dioxide is a gas that is released by the burning of coal, natural gas, oil, and wood that traps heat in the atmosphere. Atmosphere is the layer of gas around the Earth. So the Earth is covered by gas, and this gas we call atmosphere.
No atmosphere, we would be in big trouble.
Yeah.
We wouldn't have any air to breathe.
Yeah. So burning coal, burning gas, oil, wood, this creates carbon dioxide. So we can, how do we make carbon dioxide? What kind of things do you think make carbon dioxide?
Well, like it says, burning things, when we burn things, the kind of black smoke that comes up
So
contains lots of carbon dioxide.
Yeah. So factories would make lots
The
of
problem
dioxide.
being, almost everything we use comes from burning something. You may not see it, but your phone, your computer, your couch, everything comes from a factory.
So carbon dioxide also comes from cars. It can also come from airplanes. Lots of different places it comes from. Our next word is carbon footprint. Carbon footprint. So Paddy, teacher, what is your carbon footprint?
The carbon footprint is the amount of carbon dioxide one human releases into the environment in a year. So when you have the things that you do at home, or the car that you drive, or the things that you buy from the store, if it uses carbon dioxide to help make it or use it, then that makes your footprint bigger and bigger and bigger. So usually one person has a pretty small footprint, but a factory like Samsung or someone that makes furniture, they would have a big carbon footprint. So we want to make that.
The idea of a footprint, when you are walking outside, you step into the mud or step into the dirt, you will see where your foot was. It leaves a print. So you go away, you keep walking, but your footprint stays. So the idea of a carbon footprint, anything we use or make, or anything we put onto the earth, if it's smoke or pollution, it leaves that behind. Even though we're done using it, we're done making this phone or done making a car, that factory has left behind that pollution. It's left a footprint. So that's our carbon footprint.
Is having a big carbon footprint, is that good or is it bad, having a big carbon footprint?
No, not good.
Yeah, it's not good. You want a small carbon footprint.
No, that's
bad. Right. Our next, last one is fossil fuels. Fossil fuels. Right, so Andy, teacher, what are fossil fuels?
Fossil fuels are coal, oil, natural gas, which come from the breakdown of ancient plants and animals over millions of years. So the easiest way to explain this, think of something very old like the dinosaurs. Okay, we know the dinosaurs are all gone. They have died out. And we often find their bones and things underground. Well, after a very, very long time, things that are left on the earth, it starts to break down, and they become things like oil or gas. We use oil every day for our cars, for heating our homes, making electricity. But the oil is only a small amount. We can run out. Maybe one day we will, because we can't make it. It comes from millions of years ago, and in millions of years there'll be new oil. But right now, if we use it all, it's gone.
So fossil fuels, once we use them, you can't use them again. Well, you have to wait millions of years to use it again, which is too long to wait, really.
Non-renewable resource.
Alright, so let's read the main part. I'll read the first one. Right. So, climate change.
I'm going to see what is climate change, or what is the...
So, a polar bear swims through the chilly waters of the Arctic Ocean, searching for a patch of ice to climb on. Polar bears rely on sea ice for resting, hunting, and in some places raising their young. But, lately the amount of sea ice has been shrinking. Some scientists predict that the Arctic might be completely ice-free during the summer sometime this century. When that happens, this polar bear and approximately 26,000 others that call the Arctic home will be in serious danger. So this one is telling us that it's climate change will mean that the amount of ice in the ocean will get smaller and smaller. It'll start to melt, which is bad news for polar bears because they'll have nowhere to live.
Right.
It's already started to melt. In the news about a week ago, I think it was like a 20-kilometer patch of ice in Antarctica broke off. Just melted away, disappeared. Not good news for any animals living. There's no people there, but many animals, lots of wildlife, that was their home. That's where they were. But now they're going to have to move if they survived it.
Right.
The polar bears, they like to swim and catch seals, but they have to stop every once in a while and rest, and they stop on these floating pieces of ice. But if the ice is all melted, they keep swimming, and eventually there's nowhere to stop.
Yeah.
We had some more people in. We have Darby. Hey,
Hello,
Darby.
hi, Darby.
Jay from Princeton.
Hello,
Hi, Jay.
Jay.
Jiu.
Hello,
Jiu.
Jiu. I think first time saying hello to Jiu.
Yeah, Jiu. This
First
might be
to
the first
Darby
time
as
we saw
well.
you there. And Simone.
Simone, yeah,
Hello,
good.
Simone.
Burning wood, yeah, very good.
And Rousey.
Who's asking what is climate?
That would be Ricky, I think. Yep.
Well, what is climate? Well, we
Yeah, but what is climate?
Well, we already explained climate. Climate is describes what the weather is like over a long time in one place. So not just one day. One day is weather, but over a long, long time is climate.
And Rousey is Masha. So hello, Masha.
Hello.
Hi,
And
Masha.
Jeffrey, if you're watching with her.
So, for example, the desert has a hot climate.
Right.
Whereas the Arctic has a very cold climate.
And hello, Round as well.
Okay, Paddy teacher, do you want to read the
Sure.
next one? So here it is, this part.
So our next part.
All right, rising temperatures. According to NASA, the Earth's average surface temperature has increased about 1.5 degrees Fahrenheit over the past 100 years, making 2017 one of the hottest years ever recorded. Most scientists expect the climate to warm another 0.5 degrees Fahrenheit to as much as 8.6 degrees Fahrenheit by 2100. What's the big deal about a little extra heat? According to most scientists, plenty. As glaciers and polar ice sheets melt, rising sea levels could threaten coastal areas. And this global warming causes other changes to the Earth's climate, including harsher droughts, stronger hurricanes, and shifting wind and ocean patterns. Together, these changes are known as climate change.
Yeah. So this one is telling us that every year the temperature is getting hotter and hotter. So
Yeah.
this is known as global warming. Yeah.
So that small degrees of Fahrenheit, they're almost the same in Celsius. So a couple degrees, 1 or 2 degrees hotter, it doesn't seem like a big deal. Just 2 degrees
Yeah.
hotter.
But it is a big deal.
Yes.
Because it means that the ice melts, so the water in the ocean goes up. And this leads to many problems like flooding, droughts, and hurricanes.
I think of like my freezer at home. If it has the perfect temperature, but if I were to make it a little bit hotter, all of my ice and food would melt inside.
Yeah.
And it stays that temperature and it stays frozen, but you make it even a little bit hotter and I'm going to have a big puddle under my fridge.
Right. So the two big takeaways from this is, one, we have some of the hottest years they've recorded. This is only a recent thing, though. The reason this is something people talk about is this has happened in our history, but a long, long time ago. It's very strange that all at once, in a period of 10, 20 years, that we're starting to see these increases so quickly. So that's something they're worried about. And like you said, even though it seems like a little bit, it can really affect around the Earth. One of the reasons we have the climate and weather we do is from the ocean.
Right.
We call them the ocean currents. Now, if some of you if you were in our 7-year-old classes before, we've learned about ocean currents in science, how water moves around the Earth. It brings warm weather, it brings cool weather, but when the Earth temperature and climate starts to change, that can cause a problem. So areas that would be warm maybe become cold. So that's something people have argued. I don't know if you've seen this. They'll say, oh, climate change can't be real. This was the coldest winter we've had. Well, that's not a good thing either. The climate should stay around the same each year, but sometimes it becomes very hot, sometimes it becomes very cold, showing the Earth is sick.
Yeah. Yeah, global warming makes the climate change, so it might get colder as well.
Exactly.
Right. Okay, so why is it getting hotter? Well, we'll see here. So, Andy, teacher, do you want to read this part?
Certainly. So, why the warm-up? So why is the Earth changing? So what do scientists say is causing climate change? Earth is surrounded by an atmosphere made of large layers of gases. When sunlight enters the atmosphere, some of the sun's heat is trapped by the gas. While the rest escapes the atmosphere, the trapped heat keeps the Earth warm enough to live on. That's a good thing. We want some heat. Heat's good for us. But during the past few centuries, the oil, gas, and coal we use have released carbon dioxide into the atmosphere. This gas traps the heat that would otherwise escape Earth's atmosphere. This increases Earth's average temperature, which changes its climate. Climate change seems like an overwhelming problem, but you can make a difference. Keep reading for ways to live a more eco-friendly life.
Yeah. So at the end of the class, we'll look at ways that we can live a more eco-friendly life. But this one is explaining that the Earth has a gas around it. You can see it in the picture at the top. And if we burn more fossil fuels, then we put more carbon dioxide, which is another kind of gas. So if there's too much gas, then the heat from the sun can't get out and the Earth will get hotter.
There's another name for that. It's called the greenhouse effect.
Yeah.
So like a big greenhouse where you grow plants inside, we want to keep the heat because plants like heat and they need lots of heat to grow. And so we put the greenhouse on top and the heat from the sun can get in, but it can't get back out. Well, that's happening to our Earth. It's like a big shield around the Earth and it's stopping the heat from leaving. So for a little while it seems good. It's nice and warm. We get nice warm summers, but it's melting our ice.
Yeah. Long term, not good. Right.
Once again, hello to Ellie, Sophia, Olivia.
Hello, everyone.
Hello, those people.
Okay.
Darby says hello, Patty teacher.
Hello, Darby.
It says ice bears, polar
Ice
bears.
bears, polar
Okay,
bears.
yes. All right, good.
Ice Bear's a character. There's that TV show, The Three Bears. The polar bear's name is Ice Bear.
All right.
He's my favorite.
Alright, so let's just review a bit what we were reading there. So let's think what are the causes and the effects of climate change. So let's start with causes first.
Okay.
So our first cause, let's see if, can you remember what they were at home? So first one, it says that using fossil fuels leads to more carbon dioxide in the atmosphere. Or we can also call this air pollution.
Right.
Yeah.
Anything we're burning
Yeah.
to make energy.
Yeah. So what effect does, what happens with air pollution? What does air pollution cause?
The air pollution can get trapped, and that can cause the Earth to become warmer or change the climate around the Earth.
Yeah. So this one, so air pollution leads to heat not escaping, and this is called global warming.
Right.
And what does global warming lead to? Warming,
Well, it leads to a hotter Earth.
yes, which is climate
Melting
change.
ice, climate change.
So
Yep.
global warming leads to climate change. So the causes of climate change are burning fossil fuels, which leads to air pollution, which means we get more global warming, and global warming means climate change. So now what are the effects of climate change?
Nothing good.
Yeah. Well, in the text we read, there were two main effects that it was talking about. So the two effects, the effects of climate change are that the sea ice melts, and also because sea ice melts, the sea levels rise.
Right.
Yeah. So do you remember what's in the text? What was the problem for the polar bears with the sea ice melting?
It's where they
Well,
live, where they
they'll have-
find their
yeah.
food.
Yeah.
And
So melting sea ice means polar bears lose their habitat. Yeah. And what was the problem with rising sea levels? What would that lead to?
Coastal areas like Busan.
we live in Busan.
Yeah. So more flooding. There
Yeah.
was also more droughts
hurricanes
and more hurricanes.
typhoons.
So not just more of them, but also worse. They'll be worse, more severe.
So yeah, I was in Ireland this summer, and my cousin was pointing out that this weather was some of the best weather they've ever had. Ireland's usually known for quite a rainy summertime, but because of global warming and climate change, they're having a beautiful summer. However, he also showed me that that whole beach that we were standing on was much bigger the year before, that the ocean is rising. So we have a nice warm summer, but it also means that the homes and things that are near that beach may be gone in a few years. There'll be no more farmland because the water is rising, and salt water, not good for farms.
And Busan gets typhoons as well, so we might get worse typhoons and we might get more typhoons as well if there's climate change. Right. So we were talking before, what can you do? So the book told us that it would tell us some ways. So maybe here you can think back to the first slide when we were saying, is it good or is it bad? So maybe you can tell us ideas in the comments. So see what ideas you have.
Yeah, what can we do to slow down the climate change or stop it?
Yeah. Here we have 13 reasons here. We won't go through all of them, just a few of the important ones. We'll do 6 of them, which means there are 7 more reasons that we're not going to tell you. So you can maybe try and tell us, think carefully what they are, and also think back to the first slide. That will help you as well. So first one, Paddy teacher, do you want to tell us?
Sure. Used goods are good. Reduce and reuse as much as possible. Factories emit carbon dioxide when making new products. So instead of buying new stuff, fix your appliances and clothes. Good thing holy jeans are back in style.
Yeah. So if you remember the first slide, we were asking, is recycling good or bad? Is trash good or bad? Well, here it's telling us that recycling is very good.
Right.
Because it means that factories don't make so many things. So less carbon dioxide from there. And
well, this is also arguing more than just recycling. You use it again. We can recycle by, we put our plastic in a plastic trash. We put our bottles in bottle trash to go be recycled. But even that, while it uses them again, that can still make a little bit of pollution while doing that. But take that bottle, use it for something else at home.
Yeah.
You use it more than one time.
Fill it up with water again from your machine. Yep.
Yeah.
And reduce is another thing. When you go to the store and you see there are 2 things, maybe there are 2 packets of tuna, and one of them is wrapped in plastic and the other one isn't. Well, all that plastic is bad. Even though we can recycle it, we want to use less and less of things, and don't bring your own bag to the store.
Yes, that's right.
Right. Andy teacher, how about this one here? A bit of a scary one.
Slay the vampire. Ooh, okay, this took a different turn.
Yeah.
Vampire appliances suck energy even when turned off. Kill those monsters by unplugging phones, laptop chargers when not in use, and use power strips for lamps, TVs. Bonus, saves your mom and dad money on their energy bills.
Yeah.
So what this means, even when you're not using something, if it's plugged into the wall, it is using some energy. And that energy, it's electric, but we're getting that energy from factories. We have to make that electricity. Sometimes we can make it from wind. That's called renewable. But often we're burning coal to make that electricity. We're doing something that makes pollution. So the less we use, the less they need to make.
Yeah. Think of TVs that are on. If you're not watching the TV and it's on, think that it's a vampire, and you need to kill it by switching it off.
Yeah, even if it's off and the little red light is on, it's not using a lot of electricity, but it's using some. So think about turning those things off, especially if you go away on a vacation or for the weekend. Just turn all the power off in your house.
Right, next one here. Hot and cold. So wear a warm sweater instead of turning up the heat. And open your windows and turn on a fan instead of blasting the air conditioner. So again, you maybe remember in the first slide, we were asking, is the air conditioning good or bad for the environment? Well, it's bad for the environment. So instead of switching it on very high, maybe use a fan.
Right.
And same with heating. Heating is also bad for the environment.
Right.
So instead of switching that on very high, maybe just put on another sweater.
I think it is called Freon, is a chemical that goes into our air conditioner. That's why it can make cooled air. And it feels good, but what comes out of the backside is not good for the earth. You can't see it. It's not a smoke, but it is something that goes into the atmosphere, goes into the earth.
Right. And next one, Paddy teacher, do you want to tell us about this one?
All right, eat your veggies. Oh, I think my mom put this one in here. Livestock, such as cows, account for some of Earth's heat-trapping gas emissions. Yep, it's the cow toots, bangus. Eating more plants cuts down on the need for so much livestock.
Yeah. Cows make a lot of carbon dioxide.
Yes.
So if you eat vegetables, then we don't need so many cows.
Right.
then
And
there's
the other
carbon
thing, too, I didn't mention is that cows need a lot of flat land, so they cut down a lot of forests, especially in Brazil, to make space for cows. And Brazil is one of the biggest cattle producing countries in the world, but they had to cut down a lot of forest to make room for those cows. So we're taking oxygen away by not having trees, and because of all the cow farts that go up into the air.
So you can help by eating more vegetables, basically.
And less cow.
Andy teacher, how about next one here?
Walk it out. So walk or bike as much as you can. Biking or walking just 1 mile or 1 kilometer a day could save 330 pounds of carbon dioxide. That's the same as planting 4 trees and letting them grow for 10 years. Now, we are lucky. We all live in a city. It's very easy to move around the city. Some people, if they live out in the countryside, yes, you might have to drive in your car, and driving's not always bad. And we're making driving better in a way. I know some of you guys, when we did transportation units, you've talked about electric cars. That's a way. It's a car that's not putting any pollution in the air. Still takes some, to make the electricity for it. But we want to try not to drive around as much. Korea's been very good with it. Even the natural gas cars, the LPG.
Taxis.
The taxis, some will have. Buses. We have electric buses now. So ways you can walk or find ways not to use gas cars. Because no good really comes from them, but you get places fast.
Yeah,
But
I don't have a car.
Yeah.
You might remember in the first slide we asked, are cars good for the environment? Well, they're not very good for the environment. We also asked, is walking good for the environment, and are trees good for the environment? Well, those ones, yes.
Yes.
But if you just walk one day, if you walk 1 mile a day for a year, that's not too far. That's the same as planting many trees, 4 trees for 10 years. So it's very good for the environment to walk instead of always taking the car. And last one, again, there's many other ones, so maybe you have other ideas. So last one, be a science champion. So not everybody understands climate change. Learn the facts and talk to your friends and family. If everyone gets the science, we can work together to find solutions. So now you know many things about climate change. You probably know more than other people now.
Yeah.
So you can tell them about it so that they also know and they can also help the environment.
And the good news is the world is learning about this. It's not a secret. Many people don't want to change, but it is happening. Change is not always easy to do, but if we work together, we can make it better for everyone.
So these are some ideas. What about your ideas? Do you have any other ideas of how we can change?
So how can we help the environment? What do you guys think?
So if you think back to the first slide, that we were asking things like, is riding the bus good for the environment? Is trash good for the environment? Any other ideas that you have?
And some things, big companies, so ones, like Samsung or LG, giant companies, they're finding ways to change how they do things. So we need factories. We need things to live our lives. That is true. But we're finding ways to make the factories have less pollution. So even big companies are now working together to try to make less pollution.
Think about places like Starbucks and other fast food restaurants that are no longer using plastic straws.
Plastic.
Because plastic straws, they can't really be recycled.
Nice.
Even though they're plastic and we put them in the plastic trash, they end up sitting and not being used because we can't change them into anything.
Well, Anna says that she likes vegetables,
Yes.
which is very good, yes. More
Eating
vegetables
your vegetables is always a
that
good
helps
idea.
lot. Yeah.
Plant trees.
Planting trees,
That's what I'm going to
yeah.
take from that, Jamie.
Planting trees is definitely good for the environment.
Light bulbs.
Light
Well, light bulbs have actually gotten better as well. We have in the last 10 years, we have the LED lights. They last for a very, very, very long time.
Right.
They use
Jenny-
much less
and they
electricity.
use less energy.
Right, Jenny says plant trees. Yes, that's a very good idea. Plant more trees. That's very
So
good.
anything.
Walking. Yeah, we already said that one, but yes, very good. It's not just walking though. Maybe riding the bus. So if more people ride the bus, few people drive cars.
Ride the electric bus.
Or an electric scooter.
You can also see picture of kids on bicycles, so that's very good. Can also see a picture of towels next to number 3. So using towels, if you go to a hotel, use towels more than one time, maybe, instead of always getting new ones.
Yes.
Yeah. It's also number 10, those pictures says, don't use a dryer. Sorry, Andy, teacher, I know you love your dryer.
I do love my dryer.
I don't use my dryer very
not
often.
very
I just air dry most of my clothes.
Yuri says recycling. That's good, Yuri.
Yeah, recycling, very good.
Using what we
Oh,
have.
look at that sentence.
Turn off the lights when not necessary.
Yeah, that's excellent, that one. There's also number 5 is a good one. It says that you should close the door if the aircon is on, or if the heating is on.
Yeah,
that's a
close
very
the
good
windows
idea.
and door.
Yeah.
So try to find ways where you can use less energy.
Yeah. So I think we've got lots of good ideas there.
Yeah.
I think we'll say we'll take a break now.
Okay.
Yeah, I
And
think
then
it's a
we'll
good
come
time.
back.
Good pause point. When we come back, we're gonna kind of stay on the similar topic of science. So we're gonna do a science experiment. I think 2. Is that right? 1. Okay, 1 science experiment and a lesson. I think you guys will enjoy it. We'll be back soon.
Plenty of good ideas. See you later.
Hello,
Welcome back.
everybody. We are back now with doing some science lesson with you today. And this is a fun one. We've done it before with some of our students, but for those of you that have never seen this, I think you'll enjoy it. What are we doing today, Patty, teacher?
Well, we're going to talk about the states of matter.
Ah,
So some of you will have to think hard if you can remember your theme science lessons from
2 years ago, I
yeah,
think.
or I mean, every year we talk about this, the three states of matter, and there's a bit of a hint in the picture you'll see in a minute.
Yeah.
Well, we're going to do a little experiment using, well, we're going to use all three states of matter in our experiment.
Yeah. So this is one. Again, some of you, I think, most of our students who have done kindergarten, our 7-year-old class, we've done this a little bit, but we're going to go more in depth today. And if you remember some of this, tell us in the chats. Join in. You can help some of the students that maybe have never seen this. So, looking at the picture, you can come up with a good guess here. There's three states of matter. The answer is not rocks, water, smoke, though. We have to think about what is a rock, what is water, and what is smoke. So, do any of you know what are the three states of matter? I know any students that used to be in 2-year-old Columbia class or 2-year-old was a Harvard class.
We definitely studied it this year.
And yeah, I know in science we did a little bit. So can anyone tell me the three states of matter? Or just one of them even? Let's see. I see you're I know you know this one.
Well, we're going to talk about what they are in a moment and what matter means. And
I'm going to play with this clay. So let's take a look at what the states of matter can be. So, New York City, right?
Times Square.
Times Square, New York. Well, this is not the state of matter, but what is matter?
What is it?
So, matter basically is everything around us.
Everything.
The table, the bottle, the clay, you, me,
The air.
air, water. If it exists, it is matter.
Yep.
It means if we can, well, even if we can't see it, it is matter. Any noun is matter. Space has matter. Earth has matter. Everything. So easiest question, if a teacher ever asks you to tell you something that has matter, you can say anything.
Anything.
And you're going to have a good answer with it.
Pizza.
Pizza. So everything has matter. It's everything that's around us. So,
Well,
what is matter made of, Patty?
what
teacher?
is matter made of? Well, matter is made of small little things, little particles called molecules.
So molecules. Can we see molecules?
Not without a very special microscope.
All right. So molecules are very, very tiny. Maybe you've seen a picture like this before. You would need a microscope, something that lets you see very, very tiny things.
Not just even one you can buy at the store. You'd have to go to a special science laboratory at the university to see a very powerful microscope. These things are really small, but everything is made up of these small molecules.
That's right. So even though they're small, it makes everything the way that it is. It's how those molecules act. So we can't see them, but if we do look closely, what we will find is they are always moving. Some move very, very, very slow. Some move very fast. And that's going to change what we have. So let's take a look. So what are the 3 states of matter?
Some people in this chat are saying that they know what they are.
You know what
Okay.
they are?
Said what they are.
Right, so keeping it a secret too.
Well, share your knowledge. Tell us, what are the 3 states of matter?
All right, a state is the way something is.
Now, what kind of matter is
Yeah.
it?
So in science, we like to use the right words for things. Scientists don't like the word thing or stuff. So state just means kind. 3 kinds of matter, 3 states of matter.
Now, a good way to think about this, think about anything that you can see or touch. Jenny thinks she knows one. Jamie, well, liquid. Water is a liquid. Liquid is anything that is like water, cola, juice, coffee. It's moving. It does not have one set shape. So we know liquid is one. What is another kind? So we have liquid. Think about anything you can see or touch, how they feel, things you can't see. Think about where is my hand right now. Now where is my hand? Oh, Jamie has another one. Solid, liquid, and solid. What is a solid, Patty?
A
teacher?
solid is something that keeps its shape. We're going to talk about those all in a minute. But usually you can think of something that is hard is a solid. But, I mean, this is soft. It's also a solid.
Now, usually if you can touch it, it's solid. There's one more. And combine. Who was combine? That was Jenny, I think. Who was combine? You got the answer. I just don't remember which student that is. Anna. No, that's not Anna. Well, good job to combine. Say your name, combine. You got it, though. Gas.
Yes.
So, the 3 states of matter: solids, liquids, and gases. Now, one of these is very easy because it's anything that's around us, really. Solids that we can touch.
Mm-hmm.
One of them is very difficult to understand because we can't really see it.
Right.
And one is liquid. Anything that is water or drink. So let's go with some of these. What is a solid?
What is a solid?
Well,
V combine is Olivia.
Olivia! That was close. Good job, Olivia. See, you
So-
remember.
A solid is something that has a definite shape. Definite means you know what it is. You can see that brick is a rectangle.
Yes.
It has a shape.
The shape is not going to change unless we make it change.
Right.
So, even now, I have clay in my hand. Okay? This clay, sure, we can full screen that. It's this shape that I made. If I put the clay down, it's going to stay that shape. I can make it change. I'm pushing it. I am the one making the change. By itself, it will not change. So you have to break it. Or this plate. If I rip the plate, I've broken it. I have changed it. It did not change by itself. So, for example, Hulk smash. So when the Hulk smashes, he is taking that solid, he is changing it.
Yes.
He has smashed it. I forgot about this one. That's probably the best slide here. Take it in for a moment. And 3, 2, 1. Bye, Hulk. So that's a solid.
All right.
So what do the molecules? So what was a molecule? Do
The
you
molecule are the very small things that make up all matter.
So we can't see the molecules unless we have a microscope. But if we look at the molecules of a solid, they're going to be very close together. So not really moving, lots of small ones as close as they can. So think about if you are riding the subway and there's many, many people and you have to try not to take up too much space. Everyone is jammed together. That is what the molecules of a solid would look like. Now again, we cannot see it unless we have a special microscope, but when we do look, that's how we see. So, what are some examples of solids?
Ah.
So what do we have first?
Well, we've got a pencil, a
Pencil.
rock, and an apple.
All of these are hard things, right? Oh, that's an old chat. I was like, oh, it causes climate change. I said that. All of these are hard things. Their shape will not change. But how can we make an apple shape change?
I can cut an apple.
We can cut an apple.
Hulk can smash an apple.
I can eat an apple.
Eat the apple.
It's pencil. When we write with the pencil, we're making it get smaller. We're taking away that shape. When you break a pencil, when you eat the pencil, don't do that. But I've had students, they would chew on the pencil. You change the shape. They will not change by themselves. So, what about a liquid?
What is a liquid?
Well,
We're getting some examples of solids.
Oh,
Other examples.
what do we got?
Ice.
chips.
Ice,
Ice,
yes.
So,
Ice and
Olivia,
cheese.
remember ice. We're going to talk about ice in a
Yes.
Yuri says table.
moment. Tables,
Table,
plates.
yep. The computer.
The computer, yeah. So, liquids, they take the shape of their container.
Aha.
So it's similar to a solid, and we can touch a liquid. The liquid does have a shape, but the shape will change. So I have here a glass of water. If I don't move it, this water, it's almost a cube shape because this bottle is almost like a cube, a little bit rounder, but it has the sides here, the top, the bottom. And if I move it, now the shape has changed. It's become longer. So wherever that water is, that is the shape it will take. It's always moving. When water is still, then that's the shape it has. But just a little bit of a thump or a bump can make the water start
Or
to move.
if I pour it on the table, it almost loses its shape. It becomes the shape of the table, which is flat.
Yeah, it tries to fill as much of that shape as it can. So the matter in liquid, we say it can flow, it can move. Solid molecules are not going to do that. So the molecules of liquid, they're still close together, but they move a little bit. So again, I said think about a subway. You're trying to squeeze on and you're trying to move out of the way and you can't be comfortable. That's the molecules of the liquid. You're moving around a little bit.
Maybe the door opens and people are
People
going
come
in and out.
come out. Good. So, what are some examples of liquids? Do you guys know any? Oh, we already have some here. Olivia, you're lighting it up here. Coffee, tea,
One of my
juice.
favorite liquids.
Jamie also said juice.
Jamie has juice. Chloe and Uni, water. Yeah, nice guys.
Some people thought water was solid.
Well,
Water can be
can
solid.
be a solid.
That's spoilers. You gotta wait for that part. So, water, juice, and
Lava.
lava.
Yeah, it was really hard trying to think of a liquid that wasn't water. Juice is water, cola is water, but lava is not water. Lava is molten
That's right.
rock.
So
There are not many liquids that are not water-based.
No.
Mercury.
Mercury. So these are all kinds of liquids. The last state of matter, gas. So, like liquids, gases can take the shape of their container. You can fit a lot of gas into a container. This looks like it might not be much, but we could put lots of air in this. A balloon is a good example as well. You put the air in the balloon's going to start to grow. It's going to fill with as much air or as much gas as possible. Firefighters or scuba divers, that little tank, they have enough air in there for 45 minutes of breathing because that air and gas can be small and compressed.
Think about the classroom. When we're in the classroom and we're breathing the air, you could never breathe all of it, because as you open the window, more air in the door, more air can come in. It fills the room.
So, unlike liquids, gases fill the container completely. So even if I fill this bottle up with all of the water, you're still going to see maybe a little bubble of air at the top. It's very hard to fully add liquid. Liquid tries to take up all the space, but gases can do a much easier job of doing this. So what we have next, the second best slide. I think Hulk is still my favorite, but number 2. So anyone know what kind of gas makes a balloon go up? Maybe not the same, not a state of matter question, but does anyone remember the name of the gas? It's not steam, it's not oxygen.
Is it cow toots?
Could be. Starts with an H.
Ah.
If you breathe it in, it makes your voice sound like a squirrel or chipmunk.
Mickey Mouse.
Or Mickey Mouse. That is helium.
Yeah.
If you were typing it, good. So, there we go. So, the molecules of gas, they are far apart. So with these ones, they move around a little bit. They are far apart. They have lots of room to change and move. So that's how they can take the shape of really anything they need to be.
It's also why it's hard to see gases.
They are not close together. So, gas examples. You guys have already said some already. Steam.
Very good one from Olivia just now.
Nitrogen. Helium. Good. Air. Air is not just one gas. So I've seen some people who say oxygen. Oxygen is not air. We don't just breathe oxygen. If you breathe oxygen, you're going to start to feel a little bit silly. Your body doesn't quite know what to do with it. But air is a mix of, oxygen, nitrogen, a little bit of hydrogen, I believe. But helium, all together, we get the air. And we need air to breathe, to live, to breathe. People need air. Plants need air. Animals. Hydrogen, guys. Good choice there. Steam. What is steam, Patty teacher?
Steam is water vapor. So it happens when we boil water. Maybe you're making soup or ramyun or just even a really hot coffee. That gas that's coming out is water vapor.
And the last one we have on there, smoke. Smoke comes from fire. When we make something, we call that combustion. Smoke is not a good gas for people or the earth or most living things. But it's what comes up from anything that is burning. But
Unless you're making beef jerky.
It is good for making food taste delicious. That's true. So, before we get to your turn, some people were bringing up water and ice and steam. So water is a very special kind of matter in that it can be all three. So can you tell us, Patty teacher, how can water be all three states of matter?
Right. So remember that a solid has the molecules really close together, and a liquid has molecules that can move around, and a gas has molecules that are far apart that fill a container. So water can be in all three of those different states. If we make water really, really cold, we can turn it into
ice. So the molecules in the ice, they start to come together. If we were to watch the molecules of just water while we freeze it, you're going to see them a little bit further apart, moving as they're water. But then as we start to freeze, those molecules start to pack themselves together, getting closer, then it becomes hard ice.
And we know that water by itself at room temperature is a liquid. You can see that. You drink it every day.
On the other side of it, if we make water very, very hot, that water, the molecules start to expand and go away. The water cannot stay together anymore. It starts to become a gas, and that is steam. So when you breathe steam, it's not going to hurt you at all. It's just water. It's air mixed with the water.
It's a bit hot, though.
It is hot. Don't watch out for that. Well, that said, let's do an experiment that shows some of the water. Another kind of states, which we don't have on here, You could argue fire is a state of matter. Plasma. Yeah, plasma is the states. Thank you, Tom teacher.
It's coming from the chat as well. Someone said fire gas.
Okay. Oh, it's in the chat there. So for this part, what we need to know about fire is a lot like you and I. It needs to breathe. It needs to
Consume,
and eat. Okay. The only thing that's different about fire is it does not want to drink.
It's not happy when it's wet.
So for fire to live, it needs something to eat. It needs something to breathe.
So it's like a baby.
Similar, yeah. It breathes air. It needs the oxygen. Now, think about if you are swimming and you go under the water. If you go under, maybe you can stay down for 5 seconds, 10 seconds, 1 minute. Maybe you're very good at that. But after you are under the water, you start to feel, you want air. So you come back up and you probably won't go, you're going to go, because your body really wants air. Fire's the same. If we take away the fire's air, it doesn't just die. It's going to work hard to find that air. It does not want to go away. So what we're going to do today is see what happens if we have fire and we give it something to eat, we give it air to breathe, but what will that fire do if we take away its air? So, it is your turn to try.
Lots and lots of excitement on the chat.
So, some of you, I know some of you, we've done this lesson years ago. So, your turn to try. So, what we're going to try, we don't need the balloon parts, but what I want to practice is making the fire. So,
Okay.
first thing we need, take your clay patty, teacher.
Sure.
And the clay is just so we can hold up our candle. So, I have a bottle and clay. We're going to make sure the bottle can cover the clay. Make sure that it can go over it. If it fits, then you're good. And stick your clay in the middle of your plate. So just like this.
Want a little bit on the outside?
Should be. You can push it down. We want it to be
Seal.
a little bit open. Mine's a little bit too big. We don't need much. So then I should be able to put my bottle over the clay. Just like this. So once that fits, take your candle, put the candle in the clay. The clay part's not important. That is only to hold up our bottle. Now, the next thing we want to do, we're going to take our water.
We can read those together there. Number 2.
Yeah, pour colored water into the dish.
Okay, we have to make some colored water.
So can you show us, Patty teacher, how to make colored water?
Oh, that's easy. We've got some blue food dye there, and I've got my container of water. So I'm gonna put the couple drops.
This is very goopy.
That's not liquid.
What is yours?
Yeah, what is mine doing?
Uh-oh. Plasma.
Get in there, buddy.
Probably use some of mine.
I'm just gonna throw in science at the wall. Okay, we're gonna. Yeah, I'm gonna borrow some of yours, Patty teacher, if I could.
All right, we'll do this the fast way.
There we go. Why not all? Why not all?
Why do we need colored water, Andy teacher?
Well, you don't, is the short answer, but this will make it easier for you to see because water is clear and harder to see on our camera. So, we both have blue water. And what we're going to do, pour your water on the plate. So it says part 2, pour colored water on the dish. So we're going to dump this in. And it's going to go around our clay. Yeah, why not all? You have a little less, I have a little more. So the next thing is light the candle. So this part, we want mom or dad or teacher to help. Do not use the matches on your own.
Mm-hmm.
You can use anything really to light. So I'm going to light here.
Happy birthday.
Ooh. So now we have to work fast before our candles burn out. So what it says here, cover the water with the bottle.
Okay.
We're going to see, if we do that, right now our candle has oxygen. It's breathing, it's eating the candle, so it has what it needs to live. But if we cover this, there's air inside the bottle, but it won't be able to get more air. So let's see what happens. I'm going to back away.
Okay, so
a
we're
little.
going to put this on top.
One,
All
two,
the way to the bottom?
all the way to the bottom. One,
All right.
2, 3. So it's now realizing there's no more air. It's going to start to, it's going to breathe harder and harder.
Oh.
And the bottles are starting to squeeze because he's sucking as much air as he can. Now, I'm very scared to try this. Back away for a moment. I can lift the plate with the bottom. Now, if I open a little bit, it's going to try to find more air. And the water sucks up. It comes back out.
So as the candle was burning, it pulled as much of the oxygen out of the bottle as it could. If you look at my bottle, there you go.
Plate's a little bit heavy, but yeah, you can lift it up. So as Patty teacher said, yeah, it was trying its best to look for air. Just like when you come out of water or you hold your breath, your body wants more air. When we took it away, the fire was not going, but breathing very, very strongly. Okay, so guys, we hope you enjoyed our science today. We're going to be coming back on Thursday with doing, I think, a grammar class, and we're going to do another movie mimic.
Oh.
So if you need the movie mimic episode, we have a link for you. I can even post it here in the chat before we finish. Tom teacher, can I see one moment?
As soon as you stop the feed, you'll lose the...
Yeah, so here, I'm going to post the link for the mimic, and you can also get it from Sue Teacher or Rira Teacher. So I'm going to put it here, and you can watch the mimic episode before Thursday, and then we're going to practice doing some of the sentences together Thursday's class. So hold on one moment. I'm going to... No.
When he's doing that, maybe I can try to do this one more time.
All right, here we go. Let me link you guys to this. Well, Patty Teacher's going to try attempt number 2.
All right, here we go.
Yep. Oh. Working a little.
Maybe I think the candle was a bit wet that time.
Yeah, sometimes the candle is wet.
But you can see that it's sucking the air out of the cup.
So, you have the link in YouTube here. We can also send it to you. So it's about 20-minute episode you can watch. Ooh, I'm going to back away before I get sprayed. But guys, we will see you all on Thursday. Miss you guys.
Bye-bye.
Bye-bye.